Hello and welcome to the fourth lecture video. In the previous video we described program control and the way to control the flow of a program by using if or else statements. In this video we will talk about loops. In particular we will talk about for loops. That's when we loop over a predetermined range, or while loops. That's when we loop until some condition is met. So let's begin with for loops. We use a for loop to repeat one or more commands a certain predetermined number of times. A simple example is as follows. We have for, and then in parentheses we have an int I that starts from the value 1 and then goes up until the value I equals 5. And I++ means that the step is 1. So in each loop, in each iteration, I will go to I+1. And then we open braces and we have some commands that will happen repetitively inside the loop, and then we close the braces. This program will simply output each I, but of course you can replace the cout command with multiple other commands. So this will obviously just display I from 1 and then 2, 3, 4, 5 to the screen. In general, the for loop structure looks like this. Again, you have a for, then you have some integer. So you have an int I equals 1. This is done once when you start the loop. And then you have the part that's I is lower or equal to 5. That is a check. So if this is true, then the commands inside the loop are executed. If this stops being true, then the loop ends. And I++ is done after the loop commands are executed. So I goes to the next value, I+1, after each repetition of the loop commands is done. So this will keep doing 2 and 3 as long as the check is true. Another way to do an iteration is a while loop. In a while loop, we keep repeating a set of commands as long as some condition is met. For example, here we start with an integer k equals 1, and then we can say that while k is lower than 100, keep printing the value of k on the screen, and then triple the value of k in each iteration. So that means k equals k plus 3. K equals k times 3. So if the condition inside the while statement here, test, so the test k lower than 100, if this is false the first time around, then we skip the block inside the braces and never execute those commands. If this test is true, then we keep executing those commands until this test becomes false, and then we stop and we skip the commands and keep going to the rest of the code. You can also use a do while loop. So with a while loop, the code inside the loop does not execute at all if the initial test is false. And it may be that we want the code to always execute at least once. In that case, we can use a do and while loop. So the structure of this statement would be integer k equals 1, and then you have a do, open braces, you have your command that you print k to the screen and then triple the value of k. You close the braces, and then after that you write while k lower than 100. So this structure, this do while structure, will ensure that the code inside the do loop will execute at least once, and then it will check whether the while statement here is true or not. Let's discuss a for loop again. If we want to execute a set of commands a predetermined number of times, then a for loop is best. So again, the structure is for and initial statement, a condition expression, and then an end expression, and then the statement that we want to loop over. This is almost the same as a while loop that has this structure. So first you have an initial statement, then you say while, and then inside here you have the condition expression, and then you open braces, then you have the statement that you want to loop over, and then you have the end expression, which terminates the loop. Although these two sets of commands are almost identical in the result that they give, there is a small difference that we will talk about. So again, following this structure, a more concrete example based on what we've seen already is a for loop where an integer starts from 0 and goes up to 9 and increases by 1 increment in each iteration, and we print I to the screen, and then we end the for loop. And this is almost equivalent to saying the integer I equals 0, and then while I lower than 10, I keep printing I on the screen and increase I by 1. The difference is that here I is closed inside the braces, so the value of I is not seen outside the program. However, here I have declared and initialized a variable I outside the loop, so outside these braces, which means that I will be a variable that's known to the whole program. So again, the difference is that the variable I only exists inside the for loop, but in the second case, it is declared outside the while loop, so it continues to exist afterwards, and it's known to other functions of the program. The scope of a variable is that part of the code for which it exists and can be referred to. Variables declared inside braces or blocks, or if, else, while, for statements, and so on, or certain functions, and so on. Such variables only exist in that part of the code and disappeared outside of it. They're not defined outside of these braces. So here, in this case, the variables I and X are only defined inside this for loop. So they're not accessible from outside of that for loop, outside those braces. And that means if I use this variable I equals 0 up to 10 and so on, and I define a variable X in here inside these braces, if I try to access these variables outside the loop and print them to the screen, I will get an error. This code will not compile because I and X do not exist outside the loop. One can use braces around a block of commands even without any if, for, and so on, and then the variables declared inside those braces are not visible outside. So for example, I can define integer k equals 2 and another integer h equals 3. If I enclose this integer h equals 3 statement inside braces, and then I try to print its value to the screen, the code will not compile. The code can only access this declaration, the integer k that has been declared for the whole program. But the integer h that has been declared inside those braces is only accessible in this part of the program. So the only way this program could work is if I take this statement, cout h, and put it inside those braces. Only then it would work, because then it would have access to the value of h inside those braces. Sometimes you may want to end a loop early under center conditions. To leave a loop entirely, you can use the break command. So effectively, that makes your for loop work almost like as a while loop. So I have the usual for structure here, for int I equals 0 up to I equals 5, and then I print I to the screen, and then I actually want to stop the loop when I takes the value 3. So I can say if I equals 3, break. And then if that statement is true, the program will break the for loop, and it will continue to the other commands after the for loop. To skip to the next loop iteration, one can use the command continue. So in this case, you have the same for loop as before, except now instead of break, we have continue here. And if I takes the value 3, we continue, and that skips to the next loop iteration. And then you print out the value of I plus 10 to the screen, and so on. A lot of the time we have nested loops. So that's a loop inside another loop. So all these control structures that we've described, the for, the if, and else statements, and so on, can be nested within each other in whatever way makes sense for what we are trying to do. So in this case, I may start a loop over the variable I from 1 to 4. And then for each value of I want to calculate a j, which goes from 1 to 5, and then calculate the product of I and j. So that's a pair of values. So that's a nested for loop. And a pair of values for each I and j. I calculate this product and I call it n. And inside there I have an if statement. And if the product of I and j exceeds the number 10, then I break the loop. And in each iteration, I print the product I times j. So you can copy and paste that code inside your code, your IDE in Visual Studio or CLion or Xcode, and run it and see what happens. And before we do that, let's just quickly talk about indentation. So indentation is used to make the code structure more clear. And the code inside blocks, such as for loops and if statements, is indented by one tab, usually, relative to the code outside. And that doesn't affect how the code runs. You don't have to do it. It's just for people reading the code to make the code easier to read, basically. There are various indent styles. If you use Visual Studio, it will automatically indent the code for you. And Visual Studio and CLion and so on also allow for code collapsing to hide blocks of code and matching with brackets and so on. So with that said, let's try and copy this code into our CLion. Okay, so I have open CLion. I can click on New Project, select C++20 as the language standard, and let's call this project Loops. And this created a Hello World program for me. I'm going to need using namespace std for the standard library. And then inside my main function, I'm gonna type this for loop and overwrite this code. So I'm deleting this code here. And start a for loop. Now, if I was in Visual Studio, I would get automatic indentation here, but this doesn't happen automatically with CLion. But it did happen for these braces though. And again, I open more braces. And you see that it automatically takes care of the indentation for these braces. So these braces are for the main function, these are for the first for loop, and these are for the second for loop. So it helps me understand where I am inside this nested loop structure, which can be confusing sometimes. So here I have n equals I times j in each iteration, and then I want to stop the loop when the product of I and j exceeds 10. So that's an if statement, and I can say n greater than 10, and then I could start more braces here, but I'm just going to say break. And I could change line here, but I can also leave that in this line. And then after that, I'm going to say cout, insertion character, insertion operator, and then endl. And that's it. That ends first loop and the second loop. And that's the end of the main function. So let's try and compile and see what happens. Okay, so for each value of I and j, we printed the product. So the first pair is I equals 1, j equals 1, and the product is 1. The next pair is 1, 2, with product of 2, and so on, up until we reach 5, and then at some point we exceed the product. I and j exceeds 10, and then this breaks the loop. So we get that 10, and then that breaks, and that breaks the inner loop though, but it still continues to the outside loop. So keep that in mind. So this break is enclosed inside this inner for loop. So it will only break that inner for loop. It will still repeat for another value of I and keep going until I reach 10. So you can do this by hand and see how many values you get. And also I can use these buttons here that allows for code collapsing. So if I want to collapse this inner for loop, I can click here, or I can expand it by clicking here again, or I can collapse the outside for loop by clicking here, or I can actually collapse the whole main function if I want to hide it, so that I can focus on other parts of the code. And then I can click plus again to expand it again. So this ends today's video. Thank you for watching.